Here's an update to the Water Resources Outlook from the California-Nevada River Forecast Center in Sacramento for Friday, March 8th, 2013. Manual snow course measurements were taken over the past week or two, and this information was incorporated into the forecast in the past week in our hydrologic models. As mentioned in the previous update, heavy precipitation in late November and December contributed to wetting the ground and filling the reservoirs, with the snow levels above 7,000 feet for the heaviest event around the beginning of December. Up to 20 inches of rain fell in some areas of Northern California due to an atmospheric river event during this period. These photos are from around the region based on the runoff from that event. Atmospheric rivers, as they've come to be called, are streams of warm, moist air that get pulled out of the tropical Pacific and into the mid-latitudes. They're drawn by the circulation associated with traveling winter weather systems, and the moisture is forced to rise over the mountains, with precipitation getting wrung out as the air rises and cools over the mountains. Since the air is of tropical origin, snow levels are high with these events, and the precipitation falls as liquid over a broad area, producing more runoff than normal. Now here's a schematic of the event from late November and early December 2012, and you can see the moisture streaming up from near the Hawaiian Islands into California. Atmospheric rivers like this can transport as much water as 10 to 15 times the flow of the Mississippi River. It's estimated that atmospheric rivers contribute on average about 30 to 50% of California's rains each year, usually coming in just a handful of events, with as many as 9 events in a given season. This season, we've only had one of these events. The reservoirs were able to capture much of the precipitation runoff from this heavy rain event, while later storms in December were cooler and produced a relatively deep snowpack. Precipitation shut down in late December, and subsequent precipitation was much below normal, actually setting a record for dry conditions for January and February. However, precipitation was so much above normal in December and in November that many areas in Northern California are still near or even above normal for the water year, which began October 1st. And you can see this in the green and blue colorings in Northern California. The reds and oranges and yellows are below normal precipitation, and you can see much of Nevada and Southern California are drier than normal for this water year. As far as the reservoirs go, they're generally running near their historical average for this time of year. One exception is the San Luis Reservoir, which is only at about 65% of capacity. San Luis Reservoir is part of the State Water Project and Central Valley Project. It has little natural drainage, but is instead filled by pumping water that flows through the delta. The water from San Luis is then used to move water south through the San Joaquin Valley and eventually to Southern California, aided by pumping stations along the way. Pumping restrictions in the delta earlier this season to protect endangered species contributed to the low levels currently observed at San Luis Reservoir. The Northern Sierra 8-Station Index is a long-running compilation of precipitation gauging stations that have been chosen to reflect water supply in the Northern Sierra, where the major water supply reservoirs for the state are located, including Shasta, Oroville, and Folsom. Looking at the graph, the progression in time is from left to right, and the dark blue line represents the observed precipitation for the season. Other notable years are plotted, including the wettest season, 1982-83, and the driest, 1976 and 77. The most recent wet year was the 2005-2006 year. The average is shown in light blue shading, and you can also see that currently the index is close to average for this time of year. There's a similar index for the Southern Sierra, with many reservoirs providing water for much of the agriculture in the San Joaquin and Tulare Lake basins. And here you can see that the current conditions are below average for this time of year. The recent wet weather added some precipitation to our totals and helped a little bit with water supply, but not a whole lot. The totals from this week were generally 2 inches or less in the mountains and generally about a half inch or less in the lower elevations of Northern California, Amounts were a little heavier on the coastal plain in Southern California, including the LA basin, where it's still raining as of early Friday morning. The California-Nevada River Forecast Center specializes in integrating short-term weather with hydrology to produce river forecasts and longer-term runoff forecasts that can be aggregated to produce volume forecasts, including the classical April to July runoff volumes that have been in use for many years. Here you can see the colored dots that represent these April to July runoff volumes as a percentage of normal. Across the Klamath Basin, the range is variable from about 60% of normal in the lower basin near the coast to around 80% at Upper Klamath Lake. However, in the relatively dry portion of the basin, expected runoff is well below normal, with only around 30% of normal expected for inflow to Gerber Reservoir and only about 20% for Clear Lake. In the region above Lake Shasta, draining into the upper Sacramento, runoff is projected to be about 60 to 70% of normal. In the Sierra, draining into the lower Sacramento, runoff is variable from about 40 to 60% of normal. Farther south in the Sierra, draining into the San Joaquin, runoff is projected to be 50 to 70% of normal, while farther south in the Tulare Lake drainage area, only about 30% is expected. For the east side of the Sierra, expect around 60% for the Truckee and Upper Carson, but just under 50% for the lower Carson. The Humboldt Basin in Nevada ranges from 30 to 40% in the upper basin to less than 20% in the lower basin. Now, Southern California depends in part on Colorado River water, and Lake Powell, located along the Utah-Arizona border, impounds much of the Colorado River. Projections from the Colorado River Basin Forecast Center are currently about 50% of average for the April to July runoff into Lake Powell. Additionally, using an ensemble of past seasonal weather inputs, we're able to quantify the uncertainty of these volume forecasts, essentially giving confidence bounds for how wet or how dry runoff conditions can be expected, based on the current states of the soil moisture and the mountain snowpack. At this point, the main factor that could change the forecast seasonal runoff is precipitation. If precipitation for the remainder of the season is below normal, the runoff forecast will drop even further, and if it's higher than normal, forecasts will be bumped up a bit. Using the ensemble information, we're able to determine that it's highly unlikely that runoff will meet or exceed the average in most locations for this season. Currently, short-term weather forecast information out to about 2 weeks, which is factored into our seasonal volume forecasts, shows below normal precipitation. Climate forecasts for the remainder of the season, which are not currently integrated into the volume forecasts, show below normal precipitation continuing. Thus, it appears unlikely that there will be much improvement in the water supply outlook. Recent rains in Southern California are helping to recharge groundwater, but precipitation continues to run below normal in that area. However, as mentioned previously, much of their water comes from the Colorado Basin and also from Northern California. You can track our daily forecast information on our website, www.cnrfc.noaa.gov.